University in Bellingham, and I've been with the university for about 22 years. We're kind of a much smaller operation than some of the folks I've seen around here. There's the campus there this is not tracking for some reason. Pardon me. Okay, so the campus up there in Bellingham, if you haven't been there, beautiful place. We got about 15,000 full-time students there. And we recently had our chief, if you want to call him chief engineer, Terry, retired. I kind of moved into his spot, and so there's really right now just me and another coworker, Jerry Huddle, that are taking care of about 140 general university classrooms. If you round out the departmental, we're at about, there's some of the students heading off to class there. So we're quite busy. We try to keep things simple, utilitarian, don't have a huge budget, probably preaching to the choir with a lot of you folks. So, and what I wanted to talk about today were some of the problems we see. And this is across the board, whether you're doing your own designs and installs all in-house, or if you contract out to AV integrators. Some of these problems, and when we get into these acronyms, if you don't know them, I'll define them, but EDID, mismanagement, HDCP, which high definition content issues, audio, we'll get a little bit more into that, and something I like to call TED, your total equipment database that you get out of these systems. So all in all, what you end up seeing is poor quality. So when you're looking at a system and we think about all these points here of things that can, what poor quality on a system can bring about. You know, your AV technician having to go out there and diagnose, repair things over and over again. When you've got a small staff and a lot of classrooms, that adds up. Time wasted, you know, trying to get folks in to service things. Time wasted in meetings with disgruntled faculty members. All in all, the list goes on, and especially when you get down here and having to do redesign, bring the folks back in, and do things like that. So it's really important for all of us to get these things right the first time. So today, what I'd like you to walk away with is the idea that there is a standard for AV implementation that works. It's been used by a lot of different folks in our industry. It's been applied, and it keeps on improving not every year, but about every year since it's been rewritten. It can be really a big help if you're in the procurement of AV systems. So what I want to do, and hopefully this works out because my screen isn't exactly tracking like it should here. I'm going to show you a little video. And let me kind of give you a little story ahead of this. So I'm a big proponent of training in our field. You know, a lot of folks are really proud of their CTS, their CTSIs, their CTSDs, their Crestron training. And some of the big trainers that I've always enjoyed their classes back at Infocom, which is now Avixa. I'm not going to get used to that. But I started noticing some of those folks that I had a lot of respect for weren't teaching as often, or were gone a lot of the big classes. And one of them reached out to me and said, "Hey, Gary, we want you to come to this training." Actually, it was at UNLV when I first went for the training from this organization. So let me go ahead and play that and make sure that this will work. Tell you what I'm going to do. I'm going to relaunch that. Sorry Sorry for the technical difficulties. All right, so this is just a little 3-minute video that'll give you a good introduction here.
Hello, I'm Mario Maltese, the Executive Director of the Association for Quality in Audiovisual Technology, or AQAV. Engineered audiovisual technology is now an over $100 billion industry. Did you know that about a third of that is wasted on defects, wrong products, poor or non-performance, rework, and service calls? Did you know that many defects never get on a punch list in the first place, and that users regularly work around these shortcomings? Can you appreciate the costs involved when those hours to correct the defects are converted to dollars? Did you also know that there is a proven solution that can avoid nearly all of that waste? Audiovisual technology has become very complicated and more challenging to design and install working systems. It's almost impossible to find one that was delivered on time and without a so-called punch list. Yet the AV buyer expects and deserves an engineered audiovisual system to be delivered on time, with no defects or punch lists, and expects it to perform as intended with no artifacts. So what new roles must the AV buyer play, and how does the AV provider successfully complete a job when dealing with such complicated systems? That's where AQAV comes in. AQAV is a nonprofit organization made up of volunteers that are dedicated to improving the quality of AV design and installation. AQAV searched outside the box to learn how other industries address similar problems and then applied these solutions to AV technology. It started with the creation of a standard with real-life metrics to serve as the defining criteria of a successful audiovisual system from the perspective of the AV buyer. These metrics are economical to perform, and they are in the form of simple checklists that address every major milestone in the development of a project to monitor and identify every defect in product, installation practices, and performance. It's just as your father taught you: when you build something, measure twice, cut once. Properly applied, the standard not only gives the AV buyer everything he expects and deserves, but it also produces many benefits to the AV provider as well. Higher profits, more repeat sales, more sales in general, and higher morale and retention. AQAV also has vital education and training programs to help companies apply the standard for both the AV buyer and the AV provider. To learn more about how you can join a quality movement and hear how many AV buyers and providers have already prospered by it, read on or view other videos in this series. Thank you.
Okay, so if I can get a better idea what we're doing here, get us back on the right page.
I've heard countless people say that integrating AV systems with a quality management system always adds costs. Everyone agrees that designing and installing systems with the AV 9000 standard is clearly a way to do it properly, but that no one is willing to pay for it. It's easy enough to prove that.
Okay. All right, back to the PowerPoint. Okay, so the idea of quality, and while we're talking about this, I'm going to just, if you guys have never heard of this AQAV standard, I've printed out a couple. I'll just put one on each table if you want to thumb through it. Full disclosure, I'm not here paid by AQAV. I'm purely somebody who went to their classes and enjoyed what I learned there and thought we could apply it. So feel free to pass one of these around if you just want to thumb through it and get an idea. You get to. Get an idea of what the standard's all about. The big point here is conformance to requirements. And if you, from the beginning of your design, let it be known what in the end you want to walk away with, it'll be a lot easier at every step. from design to staging to the commissioning. And here, you know, if you've ever studied any of the ideas behind quality management, a few quotes here. The first one from Philip Crosby there, who was an author and big quality advocate. Quality means fitness for use. And in our cases, we can get pretty definite and defined on what that is. And it's also a false assumption. A lot of times you think quality has to mean luxury or over the top or something like that. And it's economy of effort is a good phrase there. But Mario Maltese there, the guy in the video, real simple, quality is conformance to a requirement. So if you're really clear on what that is, you're going to have a lot easier time. So your design stage, your staging stage, if you want to call it that, and your commissioning are three areas I want to concentrate on today. So I think everybody can relate to the design stage and the final commissioning. But then in between staging there, now this kind of varies whether you're a AV integrator, you got all the stuff at your shop, getting it ready to bring it to the site, or if you're, you know, you're doing your stuff in-house. But it's that, you know, putting together the mock-ups in the workshop, checking things out. A little bit later we'll talk about, and that's a good time to catch some of those problem areas before things go awry. So keep in mind as we're talking about this, those three stages. So quality control, a lot of times when you think about this, I worked for a little bit for an electronic manufacturer, and this is kind of the way it went. You know, thing went through the assembly line, if you will. Circuit board got put into a piece of equipment, turned it on, it didn't work. It was like, well, that didn't work, pull it out, throw it in the basket. You know, we can't really do that with our classrooms. More of the idea of quality assurance, and it's, I know it's a little hard to read, but if you think about, you know, reviewing your documents back at design, reviewing with engineering, staging, and again with the commissioning and that final acceptance, if we're constantly looping back, example might be in your design review, you said, hey, we want to spot to hook up a laptop and we want, you know, this type of connection. And if the guy doing the commissioning catches that wasn't in the shop drawings, that's a good time to catch it, not when you show up there to commission and go, where can I plug in my laptop? So keeping those things in mind. So the problem areas I wanted to get into, I mentioned earlier. First one, EDID. If you're not familiar with that acronym, Extended Display Identification Data. That's that communication that goes on between a display device and your source, in this case a laptop. You know, it's behind the scenes saying, hey, I'm capable of this resolution and this aspect ratio, and I like this type of audio. And when that handshake happens, it's smooth and things work correctly. When it doesn't, things can get very frustrating. A lot of technicians out there, they know that their equipment that they're putting in can be set up differently, but the design didn't specify that. So they might just set it to bypass, or they might say, it's got a scaler in it, yet let's use that. So at the end, the finished system, the guy checking it out is like, well, what did they really want to do here? So if you have an EDID plan and address it at each stage, and it doesn't, you know, it doesn't have to be anything fancy. On the drawings, you know, little call-out circle saying, set this here to bypass. I want this to know it's connected to a Hitachi model, blah, blah. Or, nope, I want it to only know it's connected to this Extron switcher. But it's time to do that in the design stage. This, a lot of words up here, but this is an actual call-out of one of the items in the standard. And what's real important, unambiguous way of dealing with your EDID signal. You know, you can't ignore it anymore because your results at the end aren't going to turn out too good. At staging time, here we read here, the system's been configured in accordance with the designer's EDID plan. A technician in the workshop should be able to pick up the drawing and say, okay, what do I need to do? And also, what's real important is a lot of times there's a certain software. Does he have that software he needs to make that modification of the EDID settings? So, and that's, again, it's better to catch that in the shop before you're putting everything on the truck or you're back at your home place. and again, knowing what the designer's intentions were, circling back to Mario's phrase about conforming to the requirement. Then at commissioning, you know, same thing. Is it able to do the displays you want, the resolutions you want, the audio formats you want? We had here this morning, I'm not picking on these guys here, but we can see, especially when you've got embedded audio, what's going on with it, where is it going, is it stereo, what are the plans for it? So always referencing back to those decisions you made at the design stage. This kind of dovetails with HDCP, high definition content protection. Most of the times in our world, what is that going to be? It's going to be somebody trying to play probably a Blu-ray disc, and if you're not designing for that, this kind of gets into the technical part. If you want to read that, what's going on behind the scenes there, and we basically know this wasn't really a great technical thing, it's a copyright protection thing. We can't blame the people for wanting to protect their intellectual property, but if you're buying a piece of equipment and you haven't really dug into the details and found out that it was HDCP compliant, you're going to get that on your screen. And that's not what you want to find at commissioning time. And if you think about it, again, it's kind of wordy if you've never looked into this, but all the things that are happening before the keys are exchanged in this HDCP land, and it can have a delay, especially if you're kind of buying some inexpensive products that aren't working well in this world. So a few things I mentioned here is when you're checking these systems at commissioning time, make sure you're turning on every expected source. Everything's there and you're seeing it where you want. Because if something comes on that wasn't, how should we say this? If this new display comes on and it wasn't tested and it hiccups, you're going to lose your HDCP key, and then you're not going to have an image. So making sure every place where you want that signal, it's getting there. Kind of a simple one, and I've seen this happen. Folks who use a Blu-ray, that's what I would do, put a Blu-ray in the Blu-ray player and play it. But if you're in a hurry, a lot of times the menus and the previews aren't HDCP protected. And when you get in the actual movie, things go wrong. So have a little patience. I'd say take 2 discs and actually get into the movie itself, let it play a few minutes, make sure things are smooth. There wasn't really a good place to put a slide on this, but when the guys were talking in the last talk, it made me think almost everybody's doing some form of HD-based T, high definition over twisted pair cable. That's the way we're getting our HDMI signals up to the projectors these days. Look at the details. Are they speccing something like that, or are they speccing a cable like that? A nice shielded Cat6E is what I'm looking at there. So you can put a lot of money into a system, skimp on the cable, and end up with all kinds of problems there. And there's a lot more details at the, you could spend a 3-day class looking at all the details there in the standard. So audio, here we are putting in a new system. A lot of times people look at audio as like, oh, audio, we've been doing the same thing for all these years. It's a speaker on the wall, yeah, who cares? But we know in our venues, if they can't hear what you're doing, you've got some issues. Having some test instruments to just go in and know where you're starting. Simple SPL meter. Go in and take some measurements and have an idea. They talk in there about some standards like you're putting in a conference room. Maybe we want to be down below 40 dB SPL, A-weighted, or general classroom, we're up here. But going into some of these troubled spaces and doing it at different times. Classes let it out. You got a 1-hour class here and a 2-hour class still in session. What kind of ambient noise, air handling equipment, close to windows and that. So have an idea where you're starting, so when you're designing your system, you know what your starting point is to get that needed SPL level out at the audience's ear. And microphones. We see here today, they're being very cognizant of when we get questions from the audience of making sure that somebody's using the microphones. But in our big installed systems, how are they placed? What patterns are they choosing? They're just saying, yeah, we want a microphone. Well, what kind of microphone, where. Wireless mics, we're going to get a little bit more into that, but spectrum issues there. We know there's just a lot of stuff out there in the RF world these days, and making sure what you're speccing is going to work on your campus. Do you need to have a sweep done? I know it's a little expensive, but there are guys who will come out and do a sweep for you for a couple $100. Ceiling mics, you know, I know a lot of people love those, but what's up at the ceiling? Air handling ducts, fluorescent lights, lots of things going on there, so really being careful with those. And just a couple general rules. They've been around for years, and if you're a live sound guy, you probably know all these, but some people just never thought about this. I call it the NOM, number of open mics rule. There's a mathematical relationship. Every time I open another live mic on a live system, my gain before feedback is halved. Do that a few times, and what are you dealing with? You know, and granted, you know, I know some of you are audiophiles and say, well, what if I use a hypercardioid? But in general rules, more open mics, you're closer to feedback. The distance rule. The gentleman back there was really careful, making sure I get my mic up here. And I'm sure many of you have been in an event where it starts to feedback, so what do? They walk away. And, but being able to design a system that takes those parameters about your audio. Stability. I'm sure everybody here has got a room on their campus that is just an acoustic toilet bowl, for lack of a better word. And it's always rim, 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 getting ready to go into feedback. There's actually some math you can do ahead of time. Now, you don't have to do this for every room. A room like this, you know, you're not going to have those issues. But two ideas. One's called NAG, your needed acoustic gain, and your PAG, your potential acoustic gain. If you've never heard of this, some of you I know probably gone through a class on this or something, but your PAG, that's the maximum amount of gain you can get out of a system before it goes into feedback, my potential acoustic gain. And then your NAG, my needed acoustic gain. And that, a really good point here, that's what it's like for Brian. He hears me at a certain level. I want the gentleman in the back to hear me at the same level. And so what kind of dB do I need to get out of a system to do that? That's what we want, everybody to have that same experience. So some acoustic scientists got together and they came up with these measurements that are taken into an equation. But if you've never seen this, the distance from the person talking to the microphone, the distance of that person talking to the nearest speaker, and the distance of that microphone, I should say listener, and the distance of that microphone to the actual loudspeaker, wherever that's located, distance from the person talking to the furthest listener, and his distance from the nearest loudspeaker, wherever that is located. So they crunched these numbers, and they came up with a way to calculate this. What you want is, here they put it out, we always want our PAG, our potential, to be higher than our NAG, our needed. It's going to work. If it's the other way around, you're going to be always dogging that feedback. And once these systems are built, let's face it, hanging a speaker in an auditorium, that's not something that comes cheap. So there's a nice simple equation, which nobody wants to do logs and mess around with that. So what I would suggest, if you have time, if this is something you're interested in, go to Sure's website. Sure has got a great little calculator on their website. And also, if you're familiar with Electrosonics, they make those real high-end microphones. They've got like a 12-minute video that goes through this and really gets down precise. So if you've never played around with PAG and NAG equations, check it out. And again, they mention that their stability is going to be, in any way in your mind, stability is going to be an issue. It doesn't hurt to crunch these numbers. And then we get into, when we're looking at AV designs, matching. And I'm kind of getting into some granular details, just where over the years, stuff I've seen and other folks have seen. Making sure your loudspeakers and your power amplifiers match, you know. I recently was on a site where they had some nice JBLs up there and we just couldn't get any level out of them. Went out there, it was the model that, guess what? It's got a 70-volt switch on the back and they're all set to 70 volts. Minor detail, but it sure impacts your system. And do you have a way of leveling all your source inputs? These days, most of the switchers have that, but if you're going with some inexpensive gear, you might need to look into getting some little way of doing that so your system turns out balanced when you switch between sources. I call this watching out for the magic. Have you ever seen on a drawing? I'll just give you a perfect example. Wireless microphone in a rack, nice Shure ULX system, and it's got an output going into the computer for lecture capture. Well, how did they go from a balanced output on the Shure to the 3.5 millimeter unbalanced? Is it just magic? How are they going to do it? So that, again, calling that out on the details. If it's HDMI audio and we need to feed that into our house sound system, how is that going to be done? Is there a way of de-embedding that audio off the system? Something I've had to call out on a couple designs, and it's a really easy fix. Get these from B&H Photo and USB dual preamp. It's got a way of balancing your signal coming in, 2 XLRs, USB out, nice clean signal for getting that into the computer for if you're using your computer for your lecture capture. But again, minor details that can be caught back when you're doing your design review. Wireless microphones, details here. Something as simple as, this is a classroom, how are we going to deal with batteries? Okay, we're going to have a charger. Where is that charger going to be plugged in? Where's the charger located? You know, again, shuffling these things around on the drawing board before we go out and have a cabinet built. You know, let's say you're speccing batteries that the little receiver, a lot of nice receivers, you can go in and change it from alkaline to nickel metal hydride or something like that. But making sure the model you spec can work with the batteries that you plan on using. And security, you know, a lot of us have open campuses. What do you plan on doing for security with the microphones? More wireless concerns. This, again, is a call out. It's wordy, but a call out from the standard. And by S meter, they're talking about the signal meter. A really good idea, and catching this at staging time there, if any of you aren't familiar with it, over here we got our RF meter. So with that off in the rack, if you look in there and it's peaking up, you know, 2/3 of the way with RF noise, we've got an issue. I'd rather find that out at staging in the shop and say, hey, let's relocate that receiver or put the antenna somewhere else or something to deal with it because, you know, a typical problem in one of our new buildings, you know, I'm not using the microphone, but the system just keeps bursting out this noise into the speakers. So again, catching that at staging time would be the appropriate. And then a couple other things on audio to kind of round out. My timer got way off. If I can get where am I at with time? Okay, so we're doing good. Have any of you heard of Stipa? Know what Stipa is? Okay, so it looks like a lot of you aren't familiar with the Stipa. This stands for Speech Transmission Intelligibility for Public Address Systems. And it's actually a measurement. If you've ever heard the signal, it sounds really weird. It's like something going on underwater. But it's been designed to test systems for their intelligibility. And this was really important in public address systems like at an airport or a shopping mall or something like that, where they have to have clear, concise directions. You know, everybody go to this corner over here or something like that. But the folks putting in public address systems in our world have started adopting it as a good overall measurement. And you might require or ask that a Stipa reading be done. And as you can see up here, they mention 0.6 or 0.75 as being a good reference for that. If you're down below 3, then you've got, or 0.3, you've got some issues going on there. And I am not going to try that video all the time, all the trouble we had last time. But there are, has anybody heard of the company Studio Pro 6? They make a lot of little things for your iOS devices. You can go in, if you get a calibrated microphone, you can do these tests. So you can be doing these tests at your place for probably around $200 and an iPad. So a good thing there. There's also NTI makes them a little bit more expensive, but if you do a lot of your own stuff, you know, little spectrum analyzers, the Talkbox, a lot of times what they do with that, they put the Talkbox speaker 1 meter away from your microphone, run it for a couple minutes, and analyze what they're getting out at different test points. And that's another thing that's really important on the audio. Again, you can spend several days talking about this, but you know, specify where you want these tests to be taken within a room. Small room like this, we might, you know, one here, one over there, but in a big, you know, 100, 200 seat auditorium, we'd want to get real specific on where we want these measurements done. And another area, a great thing in our world are digital signal processors. If you remember, you go back 15 years ago or longer, to do what a one rack unit box could do, I'm talking about compression, limiting, ducting, parametric equalization, all that stuff. We used to have a lot of equipment in a rack, and nowadays it can be done with one RU and some software to program it. But there's so many things you can do and do wrong in that one rack unit, and if you're got an AV contractor coming in, you have to be really clear when they leave, what did you do, how did you do it, how did you measure it, and you know, it gets several levels in there. What software did you use? What was the firmware at that time? You know, because when those mess up or you go in the room and you got to make adjustments, you need to know what's going on there. I just wanted to give a suggestion here. Has anybody heard of SynAudCon, Synergetic Audio Concepts? They do some really good audio training. Pat and Brenda Brown run that organization, and some of their courses they have, you know, audio technician, audio designer, but they have one I went to a couple years ago called their OptEQ. I'll pass this around if anybody wants to look at it, but it's a really good course, and it spends 3 days showing you how to basically configure mainly the EQ functions and the filters on these boxes. You know, it's funny because, you know, I'm not picking on any integrators or anything, because I've seen people do it wrong across the board. A lot of people think, well, I always in my living room always adjusted the EQ, you know, kind of this neat pattern. It sounded real good. Well, you can't do that in a room where I want each and every one of you to have an optimal listening experience. It's not like we're sitting in our living rooms. So what Pat Brown really gets at is find out what that speaker is doing, run a sweep through that speaker and measure it, and then basically optimize your EQ settings, the OptEQ idea, for that speaker, and then just do your darndest to put it where it needs to be in the room so it won't be affected, you know, by reflections on the walls or that kind of thing. And again, if you've got a box that's capable of doing those kind of things, just being real clear on what the technician is leaving you with. Ability in that one box, like I mentioned there, you got mixers, you got EQs, you got filters, all across the board filters. You got crossovers if you're dealing with speakers that don't have internal crossovers. You got routers, you got delays, and it'd be really nice if you understood from your integrator what they did and why they did it. Okay, then what I like to call the TED, your Total Equipment Database. Back in the days of when things weren't as complicated as they are now, you were lucky to get a little maybe Excel spreadsheet that said, here's my make, model, and serial number, and date it was installed, and we'll see you later. What we need today, if you think about all the things I talked about, firmware. Firmware is really important. What version of firmware? What program did you use to program that? Of course, if it's something on the network, as the guys mentioned earlier, IP settings, you know, what VLAN is it sitting on, what passwords were used. So in the book there, I think there is a example, and at the end here I'm going to transfer over to show you just some stuff on a spreadsheet. But making sure they know what you want, having that probably go out with with your list of requirements that you're getting the really detailed TED. So at this point, what I'd like to do is what I'm going to do is switch over here, and I'm just going to bring up the actual this is an example of a TED that you would total equipment database that you'd want to get from your integrator, or if your own guys are doing it. Like I said, I know we have a mixture here of folks that contract out and those that do it in-house. But you can see there are all these things, and you can always just put NA in any of those columns if it isn't something that applies to that. And I don't know how well you can see that. That's not the biggest display, but just to give you an idea, they broke down the process here, again, going from beginning to end. Here we've got our design review, and there is a course that AQAV offers to get your CQD, Certified Quality Designer. And that first day, they basically give you a set of plans that are getting ready to go out for bid, and they want you to look at them. And they put a lot of things in there, like a projector that was spec that is no longer manufactured, a projector and screen placement that isn't going to work, that aspect ratio screen at that size, all these little details that a designer should be catching. And I'm trying to remember if at this point I put some call-outs on here, but I didn't. But as you can see, that gets really, really detailed. And you might say, wow, that might be over the top. In some cases, it might be. But on our systems here, better to do your homework than to suffer with the issues down the road. The staging checklist, again, that stuff that's going on. If you guys build up your racks and take them to the room already built, or if you're maybe just build some mock-ups to check out your programming and all that, good time to catch a lot of those things that can go wrong. And then the final commissioning, and in here is the red showing up. A few things here that I highlighted that I found very helpful. Control systems, run it through every single routine, every single sub-panel routine, every single button. Is it doing what it's supposed to do? And not to assume, yeah, this room is a match over there, and it's going to do it. And a couple other little ones up here at the top I was going to talk about. This talks about your test plan and getting really specific. Again, you can change the wording on this, but getting into what's my dB at each listening site going to be, what's my tolerance, and how am I doing that. Very important for the audio portion of your design. And then just some little things I've taken to carrying with me whenever I go out to a new install. Those little inexpensive outlet checkers you can get at Home Depot for, I don't know, $10. Use those. Try it. Just plug it in. I had a unfortunate incident of being in a room where it wasn't the AV integrator's fault. There was some electrical problems. They had a little rack they pulled out, and I said, well, let me check the DVD player. It was a little external DVD player. When I went over there, I got about a 3-inch spark from the RCA cable when I went to plug it in because the outlet had a little problem going on there. So it doesn't hurt to check those things. You might say, that's not my job. That's why we have electricians. But at the end of the day, you're the guy that's going to have to deal with the aftermath. So we're using a lot of category cable, a lot of this stuff. Make sure you're speccing that it's not going to the cheapest bid and they're putting zip ties on it, exceeding bend radiuses. You're going to have to probably label that there. Do you want the hook and loop fasteners? You want somebody that's cognizant of keeping track of what the bend radiuses are on the cable. Are they using a shielded cable, but using an unshielded RJ45 on the end? So the devil's in the details on that stuff. I was talking, I don't know if he's here, I was talking to the gentleman from Extron who does a lot of reviewing of architecture plans, and he was talking about they had a whole bunch of these guys running parallel to the 208-volt light circuit for about 6 feet. How do you think that's going to work out in the long run? So details with that. And that's about wrap it up. I'm not sure how much time I got over there. Got about 8 minutes. So what I thought I'd do is pass out, if you're interested, and just go over a little questionnaire that you might use when you're thinking about hiring an AV integrator. And I'm not sure if I have enough of these. I'll try to hand them out if you can share them. But discerning questions to ask your prospective AV supplier. And if you guys want to share those around. What I really like on there is the call out on test equipment. What are they doing for test equipment? And do they have calibrated test equipment? Because if you're going to be getting granular on your requirements, remember we want that conformance to the requirements, we want to make sure that they're able to test to that and they're able to give you a list of their calibrated test equipment. Other things, sometimes companies will say, yeah, my guys are certified. We got a couple CTSDs on the thing and a couple CTSIs or whatever. What are their requirements on the job site? You know, is every crew out there got at least a CTSI lead going around and checking things out? So making sure you're not getting the B staff on your job or something like that. Any of those on there, anybody have any questions about or any ideas? Again, I'm excited about what AQAV brings to the table on this. It's an AVO 9000. You guys, if you know about AVO 9000 stuff, it's not easy to get. They worked really hard on that. If you're interested, obviously go to aqav.org, check it out. But otherwise, I can just highly recommend in your in-house stuff that you're doing, making sure you have a really detailed commission checklist, that you're sitting down with that checklist at design time, not pulling it out, you know. I know we got Dave here from Evidex. He doesn't want you to pull out your wishes at the end of the job. He wants to know what they are at the beginning, right? So if we all communicate well, I mean, I appreciate all the integrators and folks that are doing their hard job, but I think it's that communication from our design idea to the very end that will work out. So that's all I have. Thank you. You're welcome.